Hi, this is Mark Unkefer, Executive Director of the Fiber Optic Sensing Association, and welcome to our inaugural webinar for 2023. We're very pleased to have as our first presenter Dave Cunningham of Network Integrity Systems, which was has been an active member for the association for quite some time, but in particular, Dave was our chairman last year. So we're really pleased to have him back in a slightly different capacity doing this presentation. Dave, look forward to hearing from you.
All right, well, thanks, Mark. And I want to talk today a little bit about verification of sensing systems over time and how we make sure that we're sensing what we think we're sensing. But first, just to give you a little background, if you're not familiar with me, I've been in the fiber optics industry for about 32 years. And I spent a lot of time, 22 years with Corning on the passive side of the fiber optics industry. And my last 10 years have been in the active component side of the industry, with 5 years with network integrity systems and sensing specifically. So we'll start today by doing just a brief overview of fiber optic sensing in general, so that if you're new to fiber optic sensing and you want to understand it a little bit, we'll give you just a quick primer on that, where it's used, and then we'll talk about the challenge and long-term performance. And this is where we get into the heart of the presentation. What our options are to verify that performance over time, and then deployment scenarios for how to deploy systems to help us verify the performance over time. And then we'll have a summary and a question and answer time. So if you have questions, you can put those in the question box that you have as part of your screen management, and that will allow you to get your question in the queue so that Mark can get those lined up for me at the end. So yeah, put those questions in as we go, and we'll make sure to get to as many as we can at the end. But real quick, let's just go through a brief tutorial on fiber optic sensing. Fiber optic sensing is just one type of sensor that allows you to detect things like most other sensors do, right? So we live in a world surrounded by sensors with thermometers and sensing on traffic patterns on roadways and those kind of things. And fiber optic sensing is a way to do that in a real linear fashion that's very easy and very inexpensive to deploy. So the advantages of fiber optic sensing in this airport example, we'll look at a perimeter around this airport facility here, but there's really no electronics that you need along that sensor path. The path that the sensor follows doesn't require any special additional power or anything like that. There's no electromagnetic worries. You're not going to attract lightning and those kind of things. And in harsh environments, it can really give you an advantage. Line of sight's not required for fiber optic sensing to work properly. And so if you think about a perimeter example that you would have around an airport, there's a big challenge there. The temptation might be to say, well, let's just put cameras everywhere and we can watch everything. But watching those cameras is hard. Getting all those cameras placed where you don't have any blind spots is almost impossible because of the way, just the sheer size of the facility. And they're relatively intrusive. You can generally spot cameras and understand where and how they're pointed and what their range of view is and those kind of things. And they require a lot of maintenance. So if you can have an unobtrusive sensor that you can deploy along a path and make that fiber optic cable a sensor along the entire path without requiring any power, without requiring any real electrical magic to make it work, the advantage is you have a system that's relatively low maintenance. It's there for a long life, and you can detect a lot of things with that cable. So the components of that system would be what we call an interrogator. That's the electronic device that you have at the very beginning of the system. And that electronic device receives or sends and receives pulses of light back and understands where those light backscatter originated from. And so when you take that interrogator and connect it to a cable that would go, let's say, around this facility, You can see the red line there kind of wrapping the facility. That would be a fiber optic cable. You connect an interrogator to that cable, and now you have the ability to understand the acoustics that are happening around that cable and to identify exactly where those acoustic events are happening. So you can deploy that cable on the fence around the facility. You can attach it to different types of fence and detect people attempting to climb the fence or cut the fence or crawl under the fence, those kind of things. Or you could even bury the cable in the ground and pick up foot traffic. You can pick up vehicle traffic. You can understand when someone is digging or attempting to walk up to a fence and stand there for the amount of time that you would cause concern for people who are monitoring the security of the airport. So the fiber optic sensing method is used in a lot of different places. So let's talk a little bit about where it's used. And this map is very busy, but we developed this map to kind of be able to show customers where fiber optic sensing can be deployed. And the breadth of this covers a lot of the critical infrastructure, different industries defined by the U.S. government as critical to the national way of life and well-being. But it covers everything from a substation or a nuclear facility on one end all the way over to structural health of a dam, and where a lot of people focus in our business is on these long haul networks that would connect cities or connect data centers or connect different places, and ensuring that those pathways are unaffected, but also data centers and military installations, any place you want to be able to detect either perimeter intrusions or attempted manipulation of different types of assets. Fiber optic sensing can be a very cost-effective and foolproof way to manage and secure that infrastructure. So that's kind of an overview of fiber optic sensing, what it is, and where it's used. Now I want to get into the heart of the presentation, and that is really, you've got this system that you want to deploy to detect a given event, and now you want to make sure that 5 months, 10 months, 10 years from now, it's still detecting the same way it was the day you installed it. So how do we do that? Well, so let's use a linear example here where we've got, let's say that this is a data center on the top right, and on the bottom left we've got another data center, and you connect those two with, maybe you either leased some fiber from your telecommunications vendor, or maybe you even installed this cable yourself. A lot of the larger companies are doing their own cable installations to connect their data centers together. And now your primary concern about the health of that cable is, back in the day, what I would call the diesel-powered cable locator, which backhoes the augers for putting in guardrails along a right-of-way. There's a lot of different threats that can interrupt this cable, cause havoc for your network, a lot of downtime or repair costs that you're worried about. And so what you're concerned with is the cost and reputation of repairing that network, those kind of things. So what you want to do is install a system to monitor that. And distributed acoustic sensing is a great way to do that in this example. So we're going to monitor this cable now, and we're going to understand when this guy rolls up with the backhoe and starts digging, or they start to install another cable along your right-of-way, you can understand that activity when it's happening, detect that with these interrogators that you've placed along the way, and now you have a much more resilient network that you understand the health of and understand when there are threats to that health. But over time, the day you install this, it's detecting everything you wanted to detect: backhoes, not detecting lawnmowers, but detecting a drill that's putting in new cabling, that kind of thing. So it's been configured properly, but how do you know 10 years later that it's still accurate? And so let's talk about some of the threats that you could have to the accuracy of your sensing environment that you've installed. So you put this cable in. Now we're back to our perimeter example. in the sensor environment, the interrogator itself may have develop an issue. There could be drift of the laser or some attenuation on the cable that's been deployed. If you think about this airport, maybe over here on this side, there's a tree next to the fence, and that tree, as it has grown, the root system has put pressure on the cable at that spot and caused some gradual attenuation that's happened over a matter of years. But now your detection sensitivity beyond that point has changed, and you're not really detecting things, and you have a blind spot at that point in the system that you don't really know about. Beyond just the environmental things, there are actual insider threats that we deal with a lot in the business focus that we have, where you could have an insider who has nefarious intentions, and he changes the configuration slightly on the interrogator. It still appears like it's working, but it's not detecting at the levels that you think it is, and the sensitivity. Or even a more manual method that didn't require access to the interrogator configuration options. During some kind of downtime or maintenance period, you could just swap the entire fiber out that you think that's around the airport for a fiber of the same length that's now in a spool behind the cabinet, and you think you're still sensing around the entire airport, but you're actually just not sensing anything. And that fiber substitution model was one of the methods that has, in our thought process as we were developing this, was a real risk that we uncovered. So there's other ways that this could happen. I don't want to disclose a lot of those, and don't want to give anybody ideas, but there are methods or threats to the sensor accuracy that you need to think about, and you need to test for, and make sure that over time you're still sensing those things. And so we've got the challenge identified, right? Our system could be not over time not detecting as effectively as it did the day we installed it. So how do we fix that? How do we monitor the system to make sure that it's doing what it's supposed to do? So let's talk about some options. There's 3 options that I think you really have that work. Some are better than others, but you could do some manual testing over time. Now, so that would require, tapping on the cable or manipulating the cable in some way. And the challenge with that is it's prone to error in the test method, right? Different people would do it differently. You're not going to be able to test a cable the same way every time, or, it's just the human element makes it more error prone. Long-term analysis is difficult because you're not really gathering specific data or specific targets, and how close you are to those targets. If there's any kind of shift in that test result, it's much harder to identify. Having a reasonable frequency of those tests becomes difficult. You have to remember to do it. You have to think about it. Somebody has to go actually do it and then report it back accurately. And then your insider threat still is an issue, because you could manipulate those results as they get back to the reporting mechanism, and you think that those things are being tested, but they're really not. The other option is you could simply duplicate your systems, right? You could have a completely identical system set up next to the one that you have, and the challenge there is obviously cost, right? You're going to double the cost of your systems. You would need to be in separate cables, because the cable itself needs to be tested. The complexity of the system goes up, because if you double your systems, now when there's an event, you've got 2 alarms, and how do you manage those? How do you make sure they're both closed, or not? You're not opening 2 trouble tickets for things, those kind of things. And some of the threats do still exist around insiders, and what those how they could mitigate one or both systems detection capabilities. So really the best method in a lot of cases, in everything we deal with, right, a lot of automating things is much better than manual manipulation. So if you can automate the system, you can come up with a way to be repeatable and precise in your testing. And that's one of the key things that you need when you're going through and testing these type of systems, is repeatable, precise metrics, so that over time you can have an audit trail that tells you exactly the results that you were looking for and what you saw, and then being able to test as often as needed on a schedule or on a random schedule, but on a periodic basis, and know those tests are being performed in a precise fashion. The frequency of those tests could be whatever you want it to be, but the more frequent you test, the more trends become apparent more quickly. So if you're trending toward a laser issue, you'll be able to spot that and mitigate it before you're actually having a system that's not detecting those events, and now you have an error in your system that people could get around. So automated verification was the challenge, and what we wanted to do was create a product to do that. So we created what we call our Pulse sensor verification system. This system is a rack mountable system. It's a way to do that high precision, repeatable disturbances on a cable that your interrogator can find and can talk about with the management system, and let the management system know that everything is working the way it's supposed to. And we'll talk about some of the ways to the deployment scenarios. First, I want to talk about the precision. One of the challenges for our engineering team as we were developing the product is having that precise, repeatable disturbance on the cable that you could know specifically was coming from Pulse. And the engineering team worked long and hard. There was a lot of material science involved. There's a lot of trial involved, and it's unbelievable how difficult this was to actually do. But if you're familiar with the waterfall chart, what you can see here is Pulse is able to achieve a very precise disturbance over a repeatable time frame. So if you're looking at this waterfall, your x-axis is the distance. So the pulse is at this specific spot on the cable, and over here you're looking at time, and what you're seeing is very repeatable disturbances to the cable where the pulse was installed. And then on the frequency side, if you're looking here, the x-axis is frequency and the y-axis is distance. So you can see that at this spot in the cable, I think we're at about 500 meters here, a very precise and repeatable frequency, and then the amplitude, the color, basically the amount of impact being done is represented by the color here. So you can see that it's all very tight around that 500 hertz range. And so very precise, very repeatable, and that allows you to understand over time how your cable is being affected, how your sensor is being affected. And so you can configure Pulse to work with a wide range of frequencies. So you get to configure the frequency that you want to use, the amplitude or the impact of that frequency on the cable, the duration of that event on the cable, and then even taking all three of those and creating a pattern, right? So this frequency for this amount of time at this amplitude, and then do this, and then do that, and then do this, and then do that. It takes you into a realm where you can actually verify that the pulse is configured the way that you wanted it to be, and really make insider threats even more difficult. So again, the precision and the repeatable results are key to having a verification system, and that's how you can configure the system to give you those very precise results. So let's talk about how it gets deployed actually in the field. I've got a few different scenarios here. The first one, Pulse is, I should have stated earlier, Pulse is a pass-through device. So you basically as your cable is going around your perimeter, you can deploy pulse at any point. It sits in a rack and you plug in, it has an input and an output. And so it could be placed anywhere, but really for the most effective long-term verification, it needs to be at the opposite end from the interrogator. That way, you know that your performance along the entire, along the sensor is being tested at the very end, which is the most difficult point, right? So in this scenario, we've got our cities connected here. We've got an interrogator up in the upper right. We've got our pulse deployed in the lower left. And what's going to happen is the interrogator is going to recognize the pulse signal and talk to the management system. But in order to get the whole process started, the management system is going to send a request over the network via an API to the pulse to say, go ahead and do your thing. And then what the pulse will do is it will create that disturbance on the fiber. You can see the icon here for that. That disturbance is going to get seen by the interrogator, right? And it's going to detect that and say, hey, I recognize that event, that specific combination of frequency, amplitude, and duration. I recognize that as something that is a good thing. So I'm going to detect that disturbance. I'm going to let the management system know that I detected it, and the management system is then going to say, great, all good, nothing to see here. Everything's working the way it's supposed to. This is a little different than your normal events, because usually when the management system gets an event, it wants to create an alarm and say, hey, somebody needs to react. But here, the only reaction happens if the event's not detected, right? Because the management system's going to say, hey, I need the pulse to create a disturbance. It's going to create the disturbance, and then the management system should see the results from the interrogator and alarm if it's not detected. And that's the key difference to the way we traditionally handle alarms in the traditional detection mechanisms. But if the management system doesn't get an alarm from the interrogator, something's changed. Something was supposed to happen and didn't, and we need to figure out why. And that's the value of the test, to make sure that if we can't detect the pulse, we may not be able to detect other things along the path of that cable either. We need to figure out what the issue is. So that's where the management system can talk to the pulse over the network. But there are a lot of situations, a lot of the security situations we deal with, there's gaps between networks. Networks can't talk to each other. And so the management system may be deployed somewhere where they're not able to communicate over the network to the pulse. So in that scenario, you can schedule the pulse to do testing on a periodic basis. So you tell your management system the schedule. You would set the schedule and pulse every 3 hours, every 5 hours, every 15 minutes, whatever that disturbance period needs to be. And the pulse would execute the disturbance on that schedule. And then the interrogator is going to detect that disturbance on that schedule and confirm with the management system that the event happened, and the management system knows it was supposed to happen, so it's happy, everything's good. And the management system, the only time it would create a raise a red flag would be if it was supposed to see an event at 3 p.m. and it didn't, right? If the schedule wasn't kept by the interrogator responding. And so this secure configuration that we have for Pulse allows you to schedule those events, and that's in cases best where the management system can't talk directly to the Pulse. And it still allows you a way to schedule and make sure that you have an automated way to test. Now, both of those scenarios require some use of the management system, but there's a third way that you can do this and further remove the management system from the scenario in order to make sure that there's not a software issue or some kind of alarm issue on the management system itself. And that is a manual pulse created by pushing a button on the front of the box. So the management system doesn't know that an event's getting ready to be executed because there's no schedule. It's just an ad hoc event. You can walk up to the pulse and push the button to trigger the event, trigger the disturbance on the cable. That disturbance, again, is going to get picked up by the interrogator, and the interrogator is going to see that disturbance and report it to the management system. And then what you want to do then is see the alarm on the management system saying that the system is working. And if the system, or if the management system doesn't alarm in this case, you know that you've got a compromised sensing system. So there's different ways to deploy it. You sometimes have to flip your thinking around and say, I want to see an event, it's a good thing, or I don't want to see it, it's a bad thing. But there's different methods that we can use. A lot of those were to accommodate the different ways customers may need to deploy this in order to effectively create their testing regimen. So to summarize, we live in a world surrounded by sensors, thermostats, the room sensors now that you can get for your house and know temperature room by room and air quality, humidity, those kind of things. Our traffic lights that we drive on every day are managed by sensors, and trains and everything we're surrounded by sensors in our daily lives. Fiber optic sensing is a great way to deploy linear or perimeter type of sensors in an effective fashion. And in fact, I was thinking about sensors preparing for this presentation, and I'm old enough to remember when walking up to an automatic door was a pretty cool thing, because there was this rubber pad that they had bored out of the concrete, and you step on the pad and the door would open, and it was like magic. And that's obviously been replaced with motion sensors and motion detectors, and all those things we take for granted. All those sensors have to work and have to work effectively, but in these high security scenarios where we're talking about whether it be national security or physical security of citizens and airports and different public spaces, those type of things, it's critical that those sensors be working 100% of the time. And it's important that we understand the state of our sensors all the time, and if we can do that, we can know that we have a way. If we have an automated verification method, that's the best way to ensure that we can detect what we think we can detect. And this just happened yesterday. I almost hesitated to mention it because it doesn't sound. It's such a coincidence, but I was at a high security government facility yesterday and talking with several people, and one of the gentlemen that I talked to said he had some security challenges. We were talking about how fiber optic sensing could help him, and what those different deployment mechanisms could be, and what the options were, those typical conversations that you would have with a potential customer. And his last question was, and this was unsolicited, but his last question to me was, so a year from now, when I'm audited on this implementation, how can I prove that it works? And that's the key question for all of these implementations, is how do you prove over time that this is working, especially when you install things in a really quiet environment. A cable in the ground that you're monitoring between two cities should be relatively quiet. There shouldn't be a lot of alerts. You could go days, weeks, months without any kind of event happening. So how do you know that it's detecting what you think it's detecting? And that's the whole point of the verification systems that are there. And if you don't have a verification method, I would encourage you to get one. You can do it manually. You can, duplicate systems, but whatever method you choose, you need to make sure that you're verifying your sensors over time. So we're almost done with ready for the Q&A, but you can reach me at dave.cunningham@networkintegritysystems.com if you have questions that we don't get to. And then on LinkedIn, you can find me there as well. But let's come to the Q&A and see what kind of questions we have from the guests.
Thank you very much, Dave. I kind of wanted to follow up. You talk about verification of the system itself. I assume, too, another component of verification is determining whether the response to alert is completed. Could you elaborate about how that works? And do you work with organizations to be able to attest how, for example, security personnel respond? Do they do it in a timely manner when they get an alert?
Right. So yes, there are in the management system that we use called CyberSecure, there are standard operating procedures that are kicked off anytime there's an actual alarm threshold that's met, and that requires that a case be opened, an explanation of the response that was used and what the final result was that's signed off by the person who opened the case, and that gets sent. That again, that's what gives you the audit trail. So depending on how you configure your systems and those kind of things, when your verification testing would happen, you could have those operating procedures defined for that as well, or you could just simply log those as an automatically close event, but part of your overall audit log, so that you can tell over time that you were testing and that those tests were successful.
So holistically, it can be part of a broader security
It
program.
needs to be, yes, it needs to be part of the broader security footprint, and it's going to require the involvement of the people who would respond to those challenges as well, and all those different entities that are involved, the engineers that design the system, the people who actually implement the system, and then the customers who use the system and respond to those alarms are all involved in figuring out how you want to map out your verification plan.
Thank you. Would the sensor verifier system work with any interrogator?
Yes, in theory, any acoustic interrogator should work fine. There would be, you have to integrate it into your management system and configure it, but yeah, it should be able to work with any interrogator.
And I guess following up on that, then can you add the pulse to an existing implementation? So it isn't just any interrogator, but another software.
Yes. So let's say you've got an existing implementation, and based on this, you say, hey, yeah, we really need to be doing that. My system's old. Can I still do it? Yeah, you can start with verification anytime. And it's best to do it from the start, from the inception of the system. But yeah, we could add this to any implementation over time and get it and start. It's better to start late than start never.
Now, you started with the scenario of sort of how shall I say, a very highly sensitive site, airports, and then you referenced some high security government sites. Is this just for these really high extreme security cases, or does the use case make sense elsewhere as well?
I think the use case makes sense everywhere, but yeah, I mean, if you're going to invest a large amount of money to protect, let's say, a linear asset like a pipeline or a railway, or anything that we would install these systems for, that making sure that investment is operating properly should be important to everybody who is involved with the system. So I think yes, verification should be part of a plan for all these systems that are installed. But obviously, the more risky the situation, the more verification becomes critical as opposed to just important, right? Some of these systems are detecting very small things. A leak on a pipeline starts out as a really small, event, and so if it's just a leak, right? But it's still something you need to make sure you can detect over time.
So I think I know the answer to this, but I'll let you answer the question. We talked about being able to use an existing implementation, an existing interrogator. So if fiber optic cable is already in the ground around the perimeter, I'm assuming you can use that as well.
Right. Yeah, we just need a place to install the verifier, and connected into part of that sensor. Again, generally the end of the sensor is the best place, but there is some value in other places. And but yes, it shouldn't be an issue as long as you can access the sensor to install the device. And the device does require power. It needs to be in a rack and those kind of things. So you generally where the sensor comes back out of the ground to terminate is the best place.
Now, one of the challenges with sensing is really the ability to distinguish between, how shall I say, benign events and more critical events.
Yes.
Is there a protocol to allow for testing to take place to be able to make that distinction up front, or is that something you do after the, how shall I say, the trouble ticket has been generated?
So I'm not sure I understand exactly the question, but the challenge of differentiation is a huge one, right? Because
Right.
when you're setting up these systems, you want to detect generally a pretty specific list of things, right? I use the example of I want to detect somebody digging over my cable. I don't want to detect a guy mowing the lawn, right, over my cable. So that's the reason why the precision of the verification needs to be important, and you need a very precise system so that you can detect very small changes, because that's going to affect how you differentiate benign events from real events that you need to alarm on. And a lot of times the difference in those events is pretty narrow as you would plot them out. And so the precision of your sensing is very important, and that's why you need a precise verification as opposed to just a tap on a cable.
We've described a couple of use cases, obviously the airport use case and the secure facility. Is there, assume very large facilities make sense to use this for it. Is there sort of a minimum level where perhaps it doesn't make, the economics does not work out as much?
In general, for sensing, yes, the longer the linear length, or the bigger the facility, the less expensive per meter the systems generally get. And network integrity systems, we have systems that are designed to go 80 kilometers, and we've got systems designed to be used in an office building. And so we call those our zone-based systems. And so from my perspective, sensing can be used in a lot of different ways, and we have systems that cross a lot of those different scenarios, from inside a building all the way to long distance, long haul type of situation. So from my perspective, the answer is we've got the right systems for any of those sizes, but DAS specifically, the larger the better as far as cost effectiveness.
But the particular example that got called out would be data center. So a building that was housing
Sure.
a center that perhaps doesn't have as much personnel around there. That would be a use case that would make sense for that. And does that work out? Yep, go ahead. Sorry.
And so we deploy fiber optic sensing inside data centers a lot for different applications, and making sure that cables aren't tampered with and those kind of things, and that the cages themselves are intact. All those different kind of scenarios inside a data center. But then we're seeing a lot of use cases for the data center perimeters, and also connections between data centers, like we talked about. So there's a broad range of fiber optic sensing being deployed across all those scenarios.
And can you're describing different use cases and sort of different software being used. Are there considerations they need to be separated, or can you use it all on the same same implementation?
So one of the things, one of the advantages that we have is that our solution uses the same management system, whether you're doing a perimeter, some data protection inside a data center, or connecting multiple government facilities. It's all on one screen, all in one management system. So yeah, with at least with I can't speak for everybody's, but at least with our solutions, they're all managed by the same management system. And people see a lot of benefit from that because they can cover both their inside and their outside sensing scenarios with one screen.
Next question is certainly the references the fact that there's been a lot of attention paid to the attack on power substations and sort of critical infrastructure assets that frequently are not well staffed or basically are essentially automated in nature. The question is, have you seen an uptick of interest as a result of some of those incidents in these kinds of approaches, or is that something we just need to get more word out about the opportunity?
No, we've seen a lot of interest triggered by the rash of attacks, both just a few hours away from where I'm sitting right now in North Carolina, as well as in the Northwest. There seems to be a broader trend, and that's where fiber optic sensing can really help, because you look at the electrical grid, a lot of these places are out in the middle of either they're out in the open, right, and they're very hard to secure, and so there's ways you can deploy detection around those that can help mitigate and make it more difficult for those type of attacks to A, take place, or B, at least to catch the people who are performing them. And but again, these out of the way places that aren't really paid a lot of attention to, you got to verify that the system's working over time. You can't just deploy them and sit back and hope they're still working 5 years later.
Well, thank you. We've actually come to the end of the questions, but obviously you've posted your email address, and so people have more specific questions, in particular about particular types of implementations. We have some questions about that. That would be an appropriate thing to do, to reach out to you. Another question comes up of, will this webinar be posted? And yes, it will be available on the Fiber Optic Sensing YouTube channel, which along with all our other webinars as well. So Dave, as always, thank you very much for your presentation.
Thank you, Mark. Appreciate it.